Here we go. One example, then we're going to give you guys time to work. We had a couple people missing yesterday, so we're going to try to make sure that they can catch on to this a little bit. But we start with this piece here. We have a polynomial. What is the degree this time? 4. All the ones we did yesterday were of degree 3. So that makes this different. Okay? We are going to list the p's and the q's. The p's are factors of the last number, and the q's are factors of the front coefficient. So let's start with the q's. The factors of 1 are 1 and 1. The p's are factors of 48. We got 1, 2, 3, what else? 4,
6, 8.
6, 8, 12, 16, 24, and 48. So the deal is that we want to try to find all the numbers for x that you would plug in that would result in 0. That's the goal of this. But we don't know how this factors, so we have to make guesses. Instead of just guessing any number, we're only going to guess our p's divided by our q's. And if you take each of these divided by there and list the plus or minus, you get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, 6, 8, 12, 16, 24, and 48. Oh boy. I don't really want to, I don't want to try 48. And remember, we made an announcement yesterday that you do not get what on this test?
A calculator.
Calculator. Okay, one test a year, no calculator. So what number would you like to try?
2.
I heard 1 and I heard 2. I always start with 1. We're going to plug 1 in to see if we get the result we want. I'm going to go ahead and I'm just going to run everything through synthetic division. If it works, what should be our remainder?
It's not right.
Wedge has already worked through it.
No, it's wrong.
I got a remainder of negative 60.
That's not right.
So 1 definitely did not work. I heard another option of 2.
Okay.
I'll try running through 2 to see if we get a result that works. I drop down 2. 2 times 1 is 2. Add and I get 9.
Wait, why did... Oh, never mind. Sorry.
2 times 9 is 18. 8 and 18 make 26. 2 times 26 is 52. Negative 28 and positive 52 make 24. 2 times 24 is 48. Add and I get 0. Did 2 work? Yes. So it turns out that we do know one of the factors. If 2 works, then what's the factor? X minus 2 is the factor. So what we've learned is that this thing, this x to the 4th, it factors to x minus 2 times x cubed plus 9x squared plus 26x plus 24. That's what we've learned so far. Now yesterday, every time we did it, we came up with an x squared. Now I came up with an x cubed. I don't know how to factor that, so what do?
More.
We do it again. But let's talk about some choices here. Is 2 or 1 a good option for that?
No.
Why?
Negative.
I need a negative. So Ledger sees that these are all positive. There's no way you can plug in a positive number and come out with 0. You're going to have to do a negative. So if I'm not going to do positive 1 or positive 2, what would be a next good choice? Negative 1 or negative 2. Let's try negative 2 and see what happens. So I'm going to take this polynomial, and you can always just continue on in your work and just kind of stack your synthetic division on top of each other if you want. I drop down the 1, and I multiply. I add, I multiply, I add, I multiply, and I add. Did it work?
It sure did.
So that means that if -2 works, what's the factor?
X minus 2, X plus 2.
And x, so we have x minus 2 for the first one, x plus 2 for the next one.
So not both of them?
So it turns out, to answer your question, that this factors so far to x minus 2 times x plus 2 times x squared plus 7x plus 12.
Exactly.
Notice that I am down to a second degree polynomial.
Yep.
Does that factor for us?
Yep.
What if it didn't factor?
No.
Quadratic formula. Isn't it nice that when you get down to the second degree, you can always go to the quadratic formula?
No.
Wouldn't it be pretty cool if they had a cubic formula?
They do have it.
They do.
You gotta be kidding me.
It's a page and a half long.
Oh, we're not learning it. We're not doing it.
Wouldn't it be nice if they had a formula for the quartic?
They do
Probably
it
like
4 or 5
pages
pages.
long.
I bet it's
5 pages long.
Oh,
I called
NT.
it.
You were spot
what
on.
about
Wouldn't it be nice if they had a formula for the quintic?
probably
8
like 20?
pages long.
Doesn't exist. They've actually proven in mathematics. It's very interesting. We have easy formulas for the first degree. We have quadratic formulas for the second degree. We have one for the cubic. We have one for the quartic. They've proven it's not possible to come up with one for anything above the fourth degree. It's a really cool development in mathematics that came a number of years ago, but we will only reference the quadratic formula. This does factor. We've got x minus 2 times x plus 2 times x plus 3 times x plus 4. And so, as I list my solutions, they are positive 2, negative 2, negative 3, and negative 4. We found all 4 solutions, and we found how that polynomial factors. And we are convinced there are 4 solutions, and all of them come from our choices of our rational roots. They're all found right there, aren't they? Kind of cool, huh? I wonder what that looks like as a graph. Real quick, try to sketch the graph. Sketch the graph.
Sketch it.
Sketch it.
And so as you sketch the graph, that ties in everything that we've done in this unit so far. Dividing, graphing, rational roots theorem, factoring. Everything can be put in one problem. You will test on this next week, Friday. Next week, Friday. Okay. This is a great opportunity to get a really high grade on a test.
Wait, so it starts up?
It starts up, ends up.
Think.
I'm pretty sure.
I
gotta look at W.
W Riz?
Okay. Oh, yeah.
Oh, I want to play Fortnite.
As I remember last year when they re-released the Fortnite.
Fortnite?
Yeah.
Fortnite Remix?
Remember last year when they released it?
Yep.
I had like
What do you
8 boys the next day they were gone from school because they were all parents called them all to school.
They just did that again.
Did they?
Yeah,
Brian.
they did this weekend.
Sam.
Everybody get that shade?
Wait, leave it.
Was it Brian and Sam?
Hang on.
I will not drop names. All right.
You
guys are ready to go ahead and focus on your assignment. I would like to do one more example with the 2 of you if I can, okay? Do one more with you
Just
guys.
positive and negative.
And you, okay?
Whoa.
Here we go. Let's flip back one page.
I'm so close. So you remember that? Remember the, whoops,
Positive.
Yeah.
Bang,
See?
Bam.
bam, the finger guns. Bang.
And let's do problem number 4, okay?
Quit being such a Nancy Nelly.
A Nancy Nelly? I never know. I like Nancy Nelly.
Again, the big idea is that we want to find the solutions to these. Some people said you can remember this a little bit from last year, okay? But the degree is important.
Always negative.
that tells me how many solutions I should have. I should come up with 3, okay? Second of all, we don't know how to factor that. And before, if we didn't know how to factor, we just kind of like, well, there's nothing we can do. The rational roots theorem, instead of writing it down on your previous page, rational roots theorem just says this. If there are solutions, they come from your p's divided by your q's. P's are factors of the last term. Q's are factors of the first term.
I don't know.
So your p's are 1, 2, and 4. Your q's are 1 and 3. So your choices are going to be all of these divided by all of those. So I do 1 divided by 1, which is 1. And then I do 1 divided by 3, which is 1/3. I do 2 divided by 1, which is 2. And 2 divided by 3, which is 2/3. 4 divided by 1, which is 4. And 4 divided by 3, which is 4/3.
Is that all you have to do?
So I know that that looks like a lot of choices. It looks like 12 choices. But just understand that before we listed those 12, you had an infinite number of choices. Like we reduced it from infinity down to 12. That's a pretty good deal. So now it's just a matter of making a guess. And I always, if 1 is available, I like to guess 1. It's easy to try. And you saw that I rolled it through synthetic division. You can do that and see if you get 0, or you can just plug it in. 1 cubed is 1, times 3 is 3. 1 squared is 1, times 10 is 10. 9 times 1 is 9. Minus 4, does that make 0 for us? So therefore, 1 is a solution. If 1 is a solution, that means that x minus 1 is a factor. So we do know how to factor this. We are just going to take x minus 1 and divide it into that in order to see what the quotient is. I drop the 3 and I multiply. I add, I multiply. Hi!
Hello.
How are you?
Pretty good.
I think I got everything posted online for keys, okay?
Good deal.
Scooby-Doo.
Dale.
So, what we learned is to kind of finish this off is this does factor to x minus 1 times 3x squared plus 13x plus 4. Now, if you come out with a second degree, you can always solve that. You can always factor it or use a quadratic formula. If it was a third degree, then we might have to go back to doing the rational list theorem again. This factors 2, a 3x, and an x. And I'm going to have a plus 4 and a plus 1. So my solutions will be a negative 4 and a negative 1/3.
So I can win 6 times.
Devin got one of those.
Finally, just to let you guys see, I have 3 solutions which matches with that. And the 1 comes from there, the negative 4 comes from there, and the negative 1/3 comes from there. The last thing I'm going to say is this. Suppose that it didn't factor to what we had right there. Suppose it looked like this. X minus 1 times x squared minus 5. Well, that solution is 1, but this solution this would be plus or minus the root of 5. Now notice the root of 5 is not listed there, but those aren't rational. That's an irrational number because it can't be expressed as a fraction. So this stuff only tells us about rational choices. There's not much we can say about the irrational ones. Okay? There you go. Vikings got the Titans, right?
Yeah.
Jags.
They're gonna kill them.
Justin Jefferson's.